Hi there, this is Penelope. This is DE4192. This is the 2022 syllabus on functions, so any previous videos that you might have seen, this is the one to be looking at. So topic 3, class 1 on functions. And you may ask yourself, why do engineers need to even know about functions? Well, as we'll see in a minute, a function is a special type of relationship, and that covers all sorts of formulas that you might come across. And with formulas, very often you can then draw a picture, aka a graph, and it's in doing that you can show somebody, or that you yourself can see a trend of what's happening. So what's a relation then? Whoops, that's a no, that should have been a 1, an I, not a 1. Okay, let's have a look. Y equals x squared. Now, a relationship is just the mathematical term for a formula. It's a process that returns an answer from some available information. For example, the area of a square and let's call it y, can be found by squaring the lengths of the side. So y equals x squared. General notation for a function is f of x, and we read that as f of x. It's not multiplication. It's merely notation. So f is the name of the function, and x is called the argument. Right, let's have a look at the argument in a little bit more detail. Okay, so we've got y equals x squared, or f of x equals x squared. At that stage we don't know what x is. We've got an unknown argument, but what if we do know the argument? What if we know that x is 3? Then we write it f of 3, in this case then, is 3 squared, which is 9, and because it was an area, then it would be units squared. Any letter can be used. It doesn't need to be F. You could use a Greek letter, or you could use a Greek letter on a Greek letter, or you could even use a word. It doesn't matter. Either letters, words, symbols, we can use any of them to identify or name a function. Now, we need to look at independent and dependent variables. The set of variables that are the independent variable, if we look at, say, y equals x squared, the value that we choose for x determines y. So x in this case is the independent variable, and y is the dependent variable, because it depends on what you chose for x. The domain then is the set of all independent variables. In this case, where we've got f of x equals x squared, x can be any number, x can be any real number. And to shortcut that, to write that in shorthand, we would say x is an element of R. That just means x is any real number. Now the range is the set of all, for the particular function that we're talking about, the set of all possible dependent variables and in this case y is just greater than 0 because y is positive. So the domain is the set of the, if you like, the x values, but it's not always called x. The range is the set of y values in this particular case, if that's its name. All right, so that's, we've sort of hedged around a bit. We haven't spoken what exactly a function is. A function is a relation or a rule or a formula that produces a single answer for at most one answer at a time. For example, y equals x squared. This is a function because we only get one value of y for every value of x. If we look at y equals the positive or negative square root of x, that's not a function. Because for any positive x, you're going to get two answers for y. And something like y is less than x, that's also not a function because you've got an infinite number of values of y for a given x. So if you have y is less than 3, that's a gazillion number of y values that are less than 3. So the second two there are not functions. Okay, any function then is going to have an inverse. Not quite true, but as far as you're concerned in this course, yes, it is true. The inverse of a relation or a function is the process that reverses the process of the original function. So if we have the function that says double x, then the inverse would be half x. Square t, the inverse process would be square root t. Cube mu would be take the cube root of mu, subtract 3 from beta. The inverse operation for that would be the undoing, which would be add 3 to beta. And the notation, and this is another thing where you just have to watch the notation. So if we've got a function, if the function is f of x, then the inverse is f negative 1 of x. That is just notation. It's nothing to do with powers. And the theorem says that if you take the function on the inverse, you're going to end up with where you started from, which makes sense. You add 3, then you take off 3, you're back where you started from. And similarly, if you take the inverse of the function, you start back where you were. And the proof is that that is true. And you can just try it with a number. Or you can do it algebraically. Let's do it algebraically in a moment on the next slide when we're going to test for them. Now, to find the inverse, you can do it two ways. You can either swap the variables and then find x, or you can find x and swap the variables. It doesn't really matter. So if we've got y equals 2x minus 4, So this is one way of doing it. Then we're going to say y plus 4 equals 2x. So x equals a half y plus 4. And then we're going to swap the variables around. So now y equals a half x plus 4. And that is the inverse. Whoops, squeeze it in. The other way you can do it is to swap the variables at the beginning. And now we're going to find the same thing. We're going to say x plus 4 equals 2y. Divide both sides by 2 or multiply by a half x plus 4 equals y, in this case, which is the inverse. So you can do it either way. Now let's just test that that is correct. So we've got f of x was equal to 2x minus 4, and our inverse, which we wrote as a half x plus 4, which we can just simplify as a half x plus 2. Now we want to prove this by first of all finding the function on a half x plus 2. So we're going to put a half x plus 2 into our rule. Now our rule says multiply the input, the original input, by 2, and then subtract 4. So that's going to be 2 times a half x, which would be x, 2 times 2, which is 4, minus 4, which is 0, which is x. If we do it the other way, if we start with taking the inverse on the function itself, so we're now going to put the function into that. So the inverse says halve your original, which would be 2x minus 4, and then add 2. And if we tidy that up, that's a half times 2x, which is x minus 2 plus 2, so it's x. So both times we have got x. So our finding of the inverse is correct. I want to end this video with just a very quick graph drawing exercise in Excel. We've got some numbers, some random numbers, and I'm going to swap to Excel now and show you how it works in Excel. So I've copied the numbers that were on the PowerPoint presentation into Excel, and now we're just going to draw a graph of those. Who knows what it's going to look like until we do it. So we're going to go Insert, and we're going to look for charts, and we're going to choose this scatter diagram at the bottom here. And you can choose any kind. I'm going to choose the second one, middle one in the top line, and I'm going to do that. Now it's over my graph, so I should be able to move it. There we are there. Chart title, let's call it something else. Let's call it sample graph or something, whatever. You'll notice that I've put 0.5, 0.1, 1.52, etc. on the axes. If I want to change that, I can click on the axis and, oops, my mouse isn't on the right place. Can't do it. I can edit it anyway. I'm using a very funny mouse, and change that to only putting whole units there, or however many I want to put. So you can look at it there. You can do all sorts of things with it. You can change your color. Suppose we want to do it red, we can change the framing of it and so on. We can remove the squares and so on. So we can play around with the axis titles. We can put them in there. We can see it's now put labels on the data points, and I could put a trend line in there. So it's all in there for you in Excel. Okay, thanks for watching. Bye for now.